Okay, more balancing redox. We've done a bunch of these already, so I'm not going to go through huge amounts of detail anymore. We identify that phosphorus and vanadium have been changing oxidation state. Down here, we've determined the oxidation states. So we have phosphorus being oxidized from +1 to +3. Vanadium's going from +5 down to +2. It's being reduced. Looking at the elements changing in oxidation state, one phosphorus, one vanadium, one vanadium. We're done. We can go on to worrying about electrons. All right, remember the rule. 1 electron per unit change in oxidation number. Phosphorus being oxidized from +1 to +3. That's a change of 2 units, and therefore we see there's 2 electrons involved. Vanadium's being reduced by 3 units, +5 down to +2. That means it's gaining 3 electrons. We want to match the electrons lost to electrons gained. So the coefficients associated with phosphorus need to be multiplied by 3. Those associated with vanadium by 2. So now we have the number of electrons lost equal to the number of electrons gained. The next step is to balance for charge. And looking at reaction conditions, we see it's acidic. So when we're balancing for charge, we want to add H+ ions. Okay, looking at the charge, we have 3 of these. Net charge is 0. 2 of this vanadium ion. Net charge of -6 on the reactant side. On the product side, we end up with a +4. Now, in order to balance a charge, when we're adding something positive, we're going to have to add to the reactant side. In fact, we're going to have to add 10 H+ ions so that we have a net charge of +6. Now we look at the oxygens. All right, so looking at oxygens, we have 6 oxygens here and 8 oxygens here. So we have a total of 14 oxygens on the reactant side. On the product side, just now, we have 9 oxygens. So we're 5 oxygens short on this side. To balance oxygens, we add water. Now, if we've done everything correctly to this point, the hydrogen should also balance. So we have 10 plus 9, 19 hydrogens. On this side, we have 9 plus 10, 19 hydrogens. We're done. We've done lots of these, so I'm hitting the highlights. Here, we've determined the oxidation number of manganese, and the rest of the oxidation numbers are as shown. We want to balance the atoms changing oxidation number. And we note here that bromine has a subscript 2. So before we worry about the electrons, we need to balance the bromines. Now we can connect them up and determine the electrons. All right, we have 2 bromine atoms, each changing by 1 unit, -1 to 0. So because we have 2 of them, each changing by 1 unit, that's 2 units or 2 electrons that are given up in this oxidation. This is a reduction, +7 down to +2, that's 5 units, 5 electrons. To match electrons lost to electrons gained, we multiply the coefficients associated with manganese by 2 and those associated with bromine by 5. So that changes this 2 to a 10. Now we go on to worrying about balancing for charge. We're in acidic solution, so what we have to balance charge is H+. On the reactant side, we have 2 minus 1 plus 10 that are -1 charge, total of -12. On the product side, we have a net charge of +4. Now to balance a charge by adding H+, we're going to have to add 16 H+ to the reactant side. Looking at oxygens, we have 8 on the reactant side. We don't have any on the product side, so we need to add 8 waters to bring 8 oxygens to each side. Now, if we've done everything right, the hydrogens balance. 16 hydrogens, 16 hydrogens. We're done. So we see that nitrogen and chlorine are changing oxidation number. We've determined the oxidation numbers, and before we worry about the number of electrons, we want to note that chlorine has this subscript 2, so we need to balance the chlorine before we worry about the number of electrons. So we're going to need 2 chloride ions on the product side. All right, here we figured out the electrons lost and gained. We see that there are 2 electrons involved in 2 chlorine atoms, each changing by 1 unit. And nitrogen's going from +3 to +5, so there's 2 electrons involved in that process. So since there's 2 electrons lost, 2 electrons gained as written, we're not going to change any of the existing coefficients. Let's look to charge, and we note that we're in basic solution. So what we have to balance the charge is hydroxide ions. So as written, we see we have a net -1 charge on the reactant side and -3 on the product side. Again, because we're in basic solution, we're adding hydroxide, something that's negatively charged. So that means we have to add the hydroxide to the reactant side. In fact, we have to add 2 hydroxides to bring our charge on the reactant side up to a net -3. Now we can look to oxygens. So we see that we have a net of 4 oxygen atoms on the reactant side and 3 thus far on the product side. In order to balance the oxygens, we have to add 1 more additional oxygen on the product side, which means we add a water molecule. Now, if we've done everything right, hydrogens are also balanced. 2 hydrogens, balanced, done. We've determined the oxidation numbers, matched up the elements, checked. We have 1, 1, 1, 1. Elements that are changing oxidation number are balanced, so we go on and worry about our electrons. Manganese is going from +7 down to +4. That's a reduction of 3 units, so it's gaining 3 electrons. Bromine is going from -1 all the way up to 5, so it's -1 to 0 is 1, and 0 up to 5 is 5, so a total of 6 electrons that are lost. To balance electrons lost to electrons gained, we multiply the coefficients associated with manganese by 2, and we can leave the coefficients associated with bromine at 1. Now we worry about the charge, knowing that looking forward, we're going to balance a charge with hydroxide ions since we are in basic solution. We see we have a net charge of -3 on the reactant side, -1 on the product side. So we're going to need 2 hydroxides on the product side. Now we look at the oxygens. We have 8 oxygens on the reactant side and 4 + 3, 7 oxygens on the product side. So in order to balance the oxygens, we have to add an additional oxygen onto the reactant side, which means adding a water molecule. Now if we've done everything right, our hydrogens also balance. So we have 2 hydrogens, we're balanced. So we've determined all our oxidation numbers. We note that nitrogen has a coefficient of 2 and it's changing oxidation state, so we need to balance the nitrogen. So we put 2 nitrogen monoxides on the product side. We have 2 nitrogen atoms. Each of them is going from -2 up to +2. So that's 4 units times 2 atoms, 8 electrons are being released. Here, chlorine is accepting 6 electrons, going from +5 all the way down to -1. So plus 5 to 0 is 5, plus another one for 0 to -1. So 6 total electrons are being gained, 8 lost as written. We want to balance electrons lost to gained, so the lowest common multiple of 8 and 6 is 24. So we multiply the coefficients associated with nitrogen by 3, and those associated with chlorine by 4. So now we have our electrons balanced. Next we worry about the charge. Looking at the charge, we see we have a net charge of -4 on the reactant side and -4 on the product side. We're already balanced, so we don't have to worry about adding hydroxides for the charge. Looking at the oxygens, we see we have 12 oxygens on the reactant side and just 6 oxygens on the product side. So we're going to have to add 6 water molecules to the product side. Now, if we've done everything right, we should have balanced for hydrogens. We have 12 hydrogens on the reactant side, 12 on the product side. We're done. All right, this one's a little tricky. We've assigned oxidation numbers, but we have to note that sulfur here has a subscript and arsenic has a subscript. So we need to balance the sulfurs by changing the coefficient to 2 here, and we balance the arsenic atoms with the coefficient 4. Now we can worry about electrons. So when we're looking at electrons lost and gained, we see there's 4 arsenic atoms, each changing by 5 units. Each one is going from +5 all the way down to 0. So that's 5 times 4, or 20 electrons as it's written. Sulfur, 2 of them, each are going from +2 up to +6. It's a change of 4 units. So 2, 4, 8 electrons. To balance electrons lost and gained, we consider the lowest common multiple of 20 and 8, and that's 40. So the coefficients associated with arsenic should be multiplied by 2. So that becomes an 8, and that's a 2. The coefficients associated with sulfur should be multiplied by 5. So this becomes a 10, and this a 5. Now looking at charge, we have 8 times -3 plus 5 times -2, so that's -24, -10, and -34 on the reactant side. The product side has 10 times -2 plus 2 times 0, or a -20. We look at our conditions, we see it's acidic. In acidic solution, we add H plus to balance the charge. So to balance the charge, we're going to need 14 positive charges. So that means 14 H pluses needed to be added to the reactant side. Looking at the oxygens, we have 8 times 4 plus 5 times 3, so we have 32 plus 15, 47 oxygens on the reactant side. On the product side, we have 40 oxygens. So to balance the oxygens, we need an additional 7 oxygens on the product side. So that means we need 7 waters. All right, so now if we've done everything right, our hydrogens also balance. 14 hydrogens were balanced, so we're done.